welcome to Module 5, STP Concepts. STP stands for Spanning Tree Protocol. Module 5 is entitled STP Concepts, and the objective of this module is to explain how STP enables redundancy in a Layer 2 network. This module is divided into 3 topics with the following objectives. The first one is purpose of STP, which would allow you to explain the common problems encountered in a redundant Layer 2 switch network. The second is STP operations, in which you will be able to explain how STP operates in a simple switch network. And last but not least, evolution of STP, where after learning, would allow you to be able to explain how rapid PVST Plus operates. Now, before I start explaining, don't forget to log into your NetEcad account and read all about the interesting concepts of STP as well as other modules or chapters. You will find some pictures, illustrations, animations, and videos that would help you understand more about this course. So let's start with the first topic, 5.1, Purpose of STP. Now let's talk about redundancy or redundant networks. This is a concept or an idea in which there are multiple paths or links or equipments that would serve as a failover in case the main path or the main equipment such as a switch fails. In other words, it acts like a backup. So, even if a link is lost or an equipment fails, the disruption in the network is very minimal and you, as a user, will not be disconnected from the network or the internet. But take note that redundant path in a switch network may cause physical and logical Layer 2 loops. A loop in an Ethernet LAN can cause Ethernet frames to propagate continuously, in other words, go around the network endlessly and causes the network to fail. So, where does STP or Spanning Tree Protocol comes in? STP is a loop prevention network protocol that allows for redundancy while creating loop-free Layer 2 topology. How does it do that? STP logically blocks physical loops in a Layer 2 network, preventing frames from circling the network forever. This here is an example of a loop. The links between S1, S2, and S3 forms a loop. What STP does is that it will block one of the links, in this case, trunk 2 here, so that the network will be loop-free. Also take note that S2 will drop the frame because it is received on a block port. STP recalculation. STP compensates for a failure in the network by recalculating and opening up previously blocked ports. In this topology here, trunk 1 fails as indicated by the red X here, and trunk 2, if you remember, is being blocked by STP in our previous example. So, since trunk 1 is no longer working, trunk 2 will be unblocked by STP, causing it to forward frames once again. If in case trunk 1 is fixed, STP will again block one of the links to prevent the loops from forming. Issues with redundant switch links. Path redundancy provides multiple network services by eliminating the possibility of a single point of failure. This means that where there is redundancy, a link failure will cause another link to take its place, thereby preventing disconnections. However, if multiple paths exists between two devices and there is no spanning tree protocol implementation on the switches, a layer 2 loop occurs, as we mentioned earlier. Layer 2 loops can result in MAC address table instability, link saturation, and high CPU utilization on switches and end devices, resulting in a network failure. Layer 2 does not include mechanisms to recognize and eliminate endlessly looping frames, unlike IPv4 and IPv6, which includes mechanism that limits the number of times a Layer 3 network device can retransmit a packet. In IP version 4, the TTL, or time to leave field, or hop limit field in IP version 6, is decremented by the router. When this field reaches 0, the router will drop the packet. Switches has no comparable mechanism to limit the number of times a switch retransmit a frame. That is why STP was developed to prevent loops in a Layer 2 Ethernet. Without STP enabled, Layer 2 loops can form and causing broadcast, multicast, and unknown unicast frames to loop endlessly. This can bring down a network quickly. Also, the MAC address table on a switch will constantly change with the updates from the broadcast frames, which results in MAC address database instability and can cause high CPU utilization, making the switch unable to forward frames. An unknown unicast frame is when a switch does not have a destination MAC address in its MAC address table and must forward the frames out on all ports except the ingress port. The ingress port is the port where the frame was received. Broadcast storm. What is a broadcast storm? Before we discuss that, let's have a review of what a broadcast is. A broadcast is the sending of messages or frames from one source to all destinations. So, a broadcast storm is an abnormally high number of broadcasts overwhelming the network during a specific amount of time. It can disable a network within seconds by overwhelming switches and end devices. A faulty NIC or a network interface card or a Layer 2 loop can cause broadcast storms. ARP requests are sent as broadcast and are very common. Layer 2 multicast, the sending of messages from frames from a source to multiple destinations, are forwarded the same way as broadcast by the switch. IP version 6 packets are never forwarded as a Layer 2 broadcast, but as multicast. Hosts caught in a Layer 2 loop are not accessible to other hosts on the network. Additionally, due to the constant changes in its MAC address table, the switch does not know to which port to forward unicast frames. The switch, so to speak, is now confused. So, to prevent all these issues from happening, some type of spanning tree protocol must be enabled on the switch. In Cisco switches, STP are enabled by default. This prevents Layer 2 loops from occurring. To give you a little background, STP is based on an algorithm invented by Radia Perlman while working for DEC, or Digital Equipment Corporation. And in 1985, she published a paper entitled An Algorithm for Distributed Computation of a Spanning Tree in an Extended LAN. By selecting a single root bridge where all other switches determine the single least cost path, her spanning tree algorithm, or STA, creates a loop-free topology. Root bridge will be explained later. So, by strategically placing ports in blocking state, STP can prevent loops from occurring. and STP can unblock previously blocked ports to compensate for link failures and thus provide alternate path throughout the network. Now, how does STA, or the spanning tree algorithm, creates a loop-free topology? There are four things to consider. First, selecting a root bridge. A root bridge is a switch that acts as a reference point for the entire network to build a spanning tree around. You can think of the root bridge as a boss switch. Second, block redundant path or links. This would result in only one logical path between all destinations on the network. When a port or a link is blocked, user data cannot pass through it. Third, create a loop-free topology. This means that each switch has only one single path to the root bridge, similar to branches on a tree that connects to the root of a tree. And lastly, recalculate in case of link failure. Remember earlier that if there are multiple paths, some of the paths are disabled by STP to prevent loops from occurring. If ever the path in use fails or stops working, STP recalculates the path and unblocks the necessary port to allow the redundant path to become active again. STP will also recalculate path anytime a new switch or a new inter-switch link is added to the network. Okay, this video demonstration, the use of STP in a network environment, I recommend you watch this to learn more about STP. Just log in to your account in Neticad and go to your ITNT 201 course and navigate to 5.1.8 and click play. As for this packet tracer exercise, I will demonstrate this in another video. You can download the file in 5.1.9. Just click the blue button here. And of course, don't forget to check your understanding by answering a few questions and click the check button here. You can also click the Show Me button to display the correct answers.